Can anybody tell me what we discussed in last class? Hmm? We discussed about material reviews, right? Yeah. Yes. Can anybody tell me what is the difference between normal view and material view? Guys, you should be aware of that one. What is difference? What? Yes. Normal view will store only definition of the view. Okay, whatever select statement we have defined for that, that only will store in the data dictionary. Whenever you are querying the view, it go to data dictionary and it will fetch the data definition. Okay, query definition. Whatever we have given for the view, that view definition it will take and it will execute that time. Okay, so no matter what data you are having in the table, everything will reflect in your view. Okay, but in case of materialized view, it will store internally separate table. Okay, your data will be stored in separately for each and every materialized view. It will be stored inside the one table. Okay, so to reflect your data, whatever you are doing the changes in the main table, that will get reflect only whenever you are doing the refresh. Otherwise it will be working independently. What is the advantage of materialized view? It holds the temporary DML operations. Okay, so if you want to generate the reports or something for till yesterday some periodic time, okay, so what you will do, simply you will create the material view. You can take the backup for the table, okay, into the material view. Okay, that data only will be utilized for the you can generate the whatever you want, you can do that one. Okay, so no matter that table is using in the current application or not, doesn't matter, it will be it will be working till yesterday data. Okay, so no need to maintain another copy of the table. Okay, clear? So how many ways we can do the refresh the material review? Yeah, fast refresh. Okay, what is complete refresh? Yes. Okay. So whatever data you are having in the material view table, everything will be vanished and will reinsert the data from the main table once again. Okay. If you are going with the complete refresh, it will vanish entire data from the material view table. Okay. It will recreates the records. Okay. So how you can identify whether it is completely refreshing or not? Just by identifying the row IDs, you can come to know that one, right? Okay. Next, what is fast refresh? Yes, if you are doing any DML operations on the particular record for existing records, only those records will take into the log table, and okay, and if new record anyway it will new ID it will create. For existing records only will take into the log table, and only those records only will overwrite in the table. Okay, material review table. So for that, what are the conditions mandatory? You should be having one primary key, and you should be creating the one log table. Then only you can able to create the fast refresh method. Or otherwise, you cannot create the fast refresh material reviews. Clear? Okay. So next, how many ways we can do the refresh? Normally on demand. On demand, how you can do? Anyway, that is default. You need to execute the dbmsmu package, dbmsmu.exe. for refresh method. Okay, you need to execute that. Otherwise, you can do one more thing, that is commit. Okay, so for that you need to specify the on commit keyword. Okay, after doing the DML operations, if you are using the commit keyword, automatically your changes will be reflected in your material view table. Otherwise, it won't affect. Normally, people will use on demand only, because if you are doing anyway for each and every DML operations, you will do the commit operation. That is normal thing only. Otherwise, your changes will not reflect, right? So very rarely we'll get the on commit and all. Mostly people will use the on demand only. Okay, but we are having that option. If you whatever it changes you are doing, everything I needs to get into the this one means if you are doing the commit command means there is what is the meaning of that material review? Each and every transaction will go and commit. Sir, no. Yes, sir. Are you understanding? Hello. Yeah. Okay. So mostly people will use on demand only. But still Oracle given the option to make automate. Clear? Next we can take the now onwards all the topics will be related to performance. Okay? Almost query execution, query, all DB concepts are completed. I'm going to take some noise. Venkat. Yeah, so thank you. Yeah. Till now, whatever DB concept, this are all till now whatever we discussed, right? Everything is common for all the databases. Now onwards, whatever topic we are left, okay, that and all specific to Oracle. Of course, same concepts will be there in other databases as well, but maybe may not be. Okay, till now, till here, all the database, all the concepts will be same for all the databases. This will be every all the places it will be there. Okay, till here. These are all the specific to Oracle. Synonyms is specific to Oracle. Integrity constraints, it will be similar type of things are there in SQL Server and all, but syntax will be completely different compared to one database to another database. Constraints are there in RDBMS, that is mandatory. If you are having constraints, then only you can able to control the data and all. But it will be different. Logs will be specific to Oracle. Indexes will be there in other databases, in all RDBMSs and all, but this may not be there in NoSQL databases and all. Yeah, but still we can discuss it one. If you know this concept, then only you can able to understand the few topics in other databases. Okay, so how we can retrieve the data very fast. Okay, so that and all we can discuss. Nested table will be there in all the databases. Okay, nested tables and partitions. Oh, I till now not staging. Okay, wait, sorry. Till now, I not discussed any new topic, right? Okay, no issue then. Okay, so nested tables, partitions. These two will be there in all the databases. Okay, even these are all clustering indexes. These are all the specific to performance. Integrity constraints will be there in all the RDBMSs. Okay, so let the DCL commands will be there in all the places. That's okay, common thing. Okay, let's start with indexes. Once it's completed, we'll go to constraints topic. Okay, so let's start with new topic, that is indexes. Can anybody tell me what is index? I think you might aware of that index word in your childhood days. If Telugu medium, it will be mundu mata. Hmm? Huh. I am not asking Oracle. I am asking indexes. Yes. Okay, whatever table contains, okay, you can see that in first two three pages you can able to see that index, okay, in which page which data is there, which lesson is there, okay, that page number will be there and topic name will be there, unit name and that subunits whatever you are having, okay, that and all will be there in that. Sir, no, even if you are preparing any document also, definitely in that you will be having that, okay. So which slide is containing what, okay, which page we are containing that one, okay, any, let me open any courses. This is this one second. Yeah, table of content, okay. Wait, this is loading, it is a very big one. Yeah, you might seen earlier days of education, okay. So this type of things, okay, in which chapter, which unit, where is that exactly, okay, you can go to directly this particular page and you can refer the topic. Yes or no? Okay, so any textbook, anything, okay, if you are going means, what is the advantage of this one? Guys, you should be answer, this is very simple. I am not asking any subject. Yes, okay. So matter will be there inside that one. But we can able to get that chapter, particularly in this position. Okay, okay. So if I want to go for the UDF, directly you can go to 169 lines. Directly you can open that one. Yes or no? Okay. What is he showing? It is for searching purpose. You are preparing separately one table here. Yes or no? Lesson, under that it's a topic name and you will be having the page numbers, okay. So by seeing, instead of searching each and every page, what you are doing, simply you are searching the particular row number. Of course, you know how many how much size will come for 200 pages. Directly you will go to particular of course here you will be having, as a software you will be having the particular things, okay, where if you want to open the 200 page, directly you can open. But if in physical textbook means, you you are know already 200 pages means first 100 pages you need to block, okay, simply you can open the half of the book, okay. If your textbook is having 400 pages, simply you will open the half of the book, okay, means that will be more or less it will be 200 if you are opening the half of the book. Yes or no? So what is the advantage? 200 pages you are not searching, okay, simply 200 pages you are skipping and you are selecting the that next record. Of course there will be some inside that one, again you need to check, again you need to go for the 10 or 20 pages, okay, maybe you cannot open exactly the particular record and all, okay, but still you can able to, by seeing this one you can open the particular topic. You are not opening the page by page. Yes or no? Okay, same way in Oracle also. Let's assume you are having 1 millions of records in the table. If you want to if you want to fetch the particular record and all, means here if you are opening the particular record means it is the ordered everything. Yes or no? This data is ordered. That's why you are opening the particular page. Okay, 200 page or 300 page, it is ordered, that's why you are able to open that one. If it is not ordered, even though you are having the topic name and all, you cannot open, okay. Let's assume here you are having 300 page, here you are having 200 page, here you are having 400 page, okay. Here also it will take for you also time, okay. So if everything is ordered, you can able to easily particular topics and all. Clear? Same way in Oracle also, if you are having millions of records also, if you want to fetch particular record, okay, then what you have to do, you have to insert the data. in proper order. Okay. Okay, that is not in our control. Okay, sometimes I will get the data for the some IDs, sometimes I will get the some other department data, sometimes I will get for other department data and all. Okay, but still I want to save our data in the particular order and all. Means what you will do, you will create the some indexes how you are having the physically same type of things will be having in Oracle also. Okay, what it will do now, it will take the particular, okay, whatever column you are specifying, that it will make the sort and it will store in the your database. Okay, that will be. So how you are having here, you are having the page number and corresponding topic name here you are having. Okay, in Oracle also you will be having whatever column you are creating the index. Okay, for which column you are creating the index, for that particular column you will be having the row ID along with your, if you are opening this particular page, what you are having, you will be having that content, right? Particular topic content, whatever you are having, everything you are having, right? Same way in Oracle also you will be having the row ID along with your data. Okay, that we can say offset value. Okay, let me show you that diagram. Okay, if you are creating the table and if you are creating the index, means what is index, you understood, right? Internally what is the behind topic, this one content, clear, guys? Yeah, so what Oracle will do now, if you are storing the data in your database, it will be having, okay, index will be created on particular columns. Okay, so for that you will be having that column name. Okay, that column name, index column name, that it will store, and here you will be having the offset value. Okay, offset value will be having, and what it will do, let's assume you are inserting the data into the table. Okay, some 1 to 10 IDs you are storing your data. Okay, sometimes first you will give the 10, next it will give the 5, next you will give the 8. Okay, so what system will do, you are not inserting data in your proper order, but system what it will do, all the times it will make the arrange inside that one. Okay, how internally it will do now, let me show you first diagram. So whenever you are inserting the data, it will be created your data in the tree manner, tree structure manner. Okay, first it will take your data. Okay, let's say you are inserting the first record. Okay, that it will consider, system consider as a root node. Okay, some, let's assume you are having you are inserting the data for the EMP table, that EMP ID is some 4000. Okay, clear, this is EMP ID column. Okay, 4000 you are inserting. Okay, this anyway, this is first record, definitely it will take the root node. Okay, means your data will be stored, of course you are physically, you are not storing as a tree structure, but logically it will implement inside that one. Okay, so how it will be storing, okay, for first record your ID will be stored as a 4000. Next what it will do, next you are record, you are inserting the record, that is 2947. Okay, so it will check whether that next record is less than this one or more than this one. Okay, so 2947 is less than that one. Okay, so next record will be added to the left side, this one. Okay, so the value is less than 4000, that's why it will create it as a one left side node. Okay, so 2947, just randomly I'm taking the values. Okay, next I am inserting one more record, that is 6000. Okay, so it will check, system always it will check for the this tree balancing. Okay, so next it will check for the 6000 EMP ID. What it will do, this 6000 6000 is more than that root node value, it will add at the right side. Okay, so it will add at the right side, that is 6000. Okay, next, you are inserting the data for 3200. Okay, let's assume you are inserting the data. You are created the index. Till now in Oracle I have not created any indexes at all, just topic I am explaining. Okay, next you are inserting the data for 3000 id. It will check for the, anyway it is balanced. Till now it is balanced, so it won't check for the balancing. Next it will check for the 3000 id, whether your id is less than this one or not. Okay, if it is less than, it will move to the left side. If it is more than that, it will be moving to the right side. Next again it will check for the 3000 id. Okay, it will check for the 3000. It is less than that one, it will go to left side. Okay, already left side one node is there. Again it will check for the, this value is less than this one or more than this one. So if it is more than, again it will create the right side of the this node. Okay, so this will be checking here and the value will be 3000. So system won't check for the balancing till now, because you are having only one record extra here, not having more than that one. Let's assume you are inserting again 3000, 3500. Okay, again it will be more than this one. Next it will be insert the data. Okay, just you can take the, listen this one once again, I will explain. Okay, how it will internally happen. Okay, 3500. Okay, next it will go to this node, 3500. The first 3500 will be checking here. It is value is less than this one, means it will go to left side, and again it will check for this one. It will go to this side. Okay, because it is a more than 2947. Okay, again it will check the value for the 3500. It is more than this one. Okay, again it will go for the right side only. Okay, like that nodes will be happened. But here middle element whatever is there, right, system is always trying to do the balancing. In left side you are having three nodes, but right side you will be having only one record. Now what system will do now, it will adjust. Okay, how it will adjust now, it will try to make left side 2 and right side 2. Okay, means all the times system will try to make adjustment. How it will do now, so this node will become root node now. Okay, where I can draw the diagram. I will open. Okay, same diagram will become, first root node will adjust this 2947, because left side you are having three, right side you are having only one. So if we go to this is middle, it will be adjusting. Okay, so what it will do, it will make the 2947 is the root node element. Next you will be having three, next left node will be 3000, not 3000, because it is a value is less than this one. Okay, so this value will go to this right side, because it's a more than value, right? So 3500 will go to top now. Okay, are you getting my point or not? Because value is more than this one, right? So definitely middle element will be whatever values you are containing, that in that middle element whatever you are having, that it will go to top. Okay, 3500. Next what is the value, 3000. Okay, so because 3500 is less than this one, in back side it will search that one. Okay, this is left side one node will add, right side one node will add, that is 3000. It will be adjusted to the left side node, and right side will be adjusted the, this 4000 will become the leaf node. Okay, so it will make the 4000 now. Next again you are having the 2947 which is less than 3000, so that will be created at left side. Just listen this word again, I will explain what I am saying, how internally it will works. 2947. Okay, so one more value is there, 6000, which is less than more than 4000, so that will be added to the this right side. Okay, this you are clear, right? 6000. Okay, so like this it will be added. Of course, now this is balancing. Now your data will be stored. Okay, whenever you are searching your data, okay, for the 2947, first it will go for the 3500. It will check whether value is less than or not. Okay, so which is less than this 3500, it will go to left side, means you are avoiding the right side nodes and all. Okay, means half of the records you are avoiding for searching. Okay, next it will go to 300. Okay, so here also value is less than this one, it will go to left side. Let's assume you are having some right side nodes also. Again you are having one more node here. Okay, let's assume you are having so many nodes here for this one. Okay, and here also this one, and this one, and here this one. Okay, like this you are having. Okay, like this you are having n number of nodes, means what will happen, you are avoiding the searching in the this many nodes, means you are searching in the only this manner. Okay, it will go to first, you are searching for the one element. Okay, that is 2947 or something. Okay, so you will get reduced number of nodes whatever you are having. Okay, so if you are having this one, so you are avoiding so many nodes. Okay, you are searching only left side nodes only. Okay, so you will find the at in 10 to 1 to 10 number of nodes, you will come to know your value is how many, where you are having the particular value. So if you are avoiding this many searches, means you would definitely will find in left side only. Okay, because value is less than that one. So you are avoiding this many, means your execution time will get reduced. Yes or no? If you are opening page by page, what will happen, you will take more time to open the particular page. But if you are opening this particular half of the book, means so half of the book scanning will be avoided. Yes or no? Guys, yeah, everything for all that till now whatever you we are discussed, right? Everything specific to no matter how much theory you learned, that and all doesn't matter. But now onwards, if you are going with the performance, means definitely you should be having very good knowledge of theoretical. Okay, theoretically how internally it will works. Okay, that should be clear. That's why I'm explaining the theory first. Yeah, of course, I have explained for other topics as well, theory and all, but I concentrated more on uh, practical. But here you should be concentrated on theory, how internally it will works. It's a matter practically nothing is there. Simply create index name on particular table. Nothing is there for that. But internally how it will works, you should be aware of that one. Okay, how index will be performed more better. Okay, without index also you can able to scan that one. Okay, if you want particular index. Okay, I want to open, I want to get the employee id 737934. What you will do, simply where emp number equal to 7934. If you are giving like that, means you will be getting the data. Let's assume you are having some millions of record. If you want to find that particular employee number, you it will be taking the more time. Okay, in real time you will be having more number of records. That time it will take lot of time for searching the particular employee number and all. Okay, so for that what you will do, you will be creating the some indexes. Okay, how indexes will give better performance and all, means the data will be insert the data in proper order. Okay, so it will check, it will logically it will creates the tree structure, and it will avoid the number of records scanning. Okay, so if you want to get some 1800 employee id. Okay, 1800 employee id you want, simply normally what you have to do, if your data is not in the particular order, what will happen, it will go and search each and every node. Okay, and it will come to in last 1800. But if you are creating the indexes, all the time system will adjust the balancing and all. This we can say whatever your adjustment you are doing, right? This we can say re-indexing. Okay, this will be happened and your data will be sorted. Okay, based upon particular id, it will be balancing all the times, it will go for the re-indexing. Okay, so that what will happen, of course, dml operations while inserting the data, dml operations will take time for committing the data, because all the times it will check for the balancing. But instead of insertion, in real time searching will be very important. Data scanning is having more important. Okay, so anyway, for dml operations will take time. It everything will always, it will be balancing only. So for particular record only, it will, if you want to go and search means, what you will do, you will create the indexes and it will scan in this way. So if you are avoiding this many number of nodes scanning means, you will easily find, identify the particular id. Yes or no? How many number of records you scan now? One, two, three, four for identifying the 18 records. But you are having some 20 nodes here. Okay. But you are not scanning all 20 nodes. We are scanning only 4 nodes by the okay. So to make this, you are getting better performance or not with this. Okay, in this manner your data will be your indexes will be performed. Okay, so how internally it will works now, whenever you are creating the index, internally it will creates one more table parallelly. Okay, so this data only storing in like this. If we are adding one n number of records means, it will be all the times whenever you are doing a commit, all the times it will be reclustering. Okay, means re-indexing will happen. Okay, your data will be structured in this data will be showing. Of course, internally it won't store in tree structure. Logically it will create that one. Means how physically it will store your data na, internally it will creates one more table for your table, index table only, index column only. Okay, not for the entire column, entire data. For index column, we will created one more table, that is index table. Okay, you cannot able to see the data. Okay, this is index column. Next you will be having the, already I told you will be having the offset. So if your data is in proper order, you easily, if you are having the row ID, simply you can go and you can search your row ID or not. Easily it will scan that one. Yes or no? Okay. I told right, your data will be stored in the form of blocks, files. Okay. Inside blocks, you will be having different number of files, and in that file also you will be having the, each and every row you will be having the particular address. That is clear, right? Yes or no? Okay, that will be stored in your index table. If you are creating the index, internally it will creates the separate table that you cannot able to see, that is oracle maintained. Okay, of course, material review and all you can able to see the table name also, but index column, index table, it won't store, you cannot see the your table inside the your database, but internally it will work same way. Okay, arithmetic, they written in machine learning language for the index thing, it will create the separate table. For that your data will be stored inside the index table. Okay, how it will be stored now, it will be having with order. Okay, let's assume your data is now some 1800 and for 2000. Okay, so whatever you are having the data, that will be stored as a separate row, and here you will be having the particular 1800 for column, whatever you are having, right? That row IDs will be there. And next it will create the n number of rows like this. Okay, some 2000. Next 2197. Okay, it will be stored data in ascending order. No, 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 that should be. 3800 means you will be having the more. Okay, it will be ascending order. Just for example I'm telling. Let's assume you are having some 1800 to 1600, you are having the values and all. How it will search now? If you want to search for 1800 element system, what it will do? System will be having your header information, index table information. Okay, how many number of rows you are having in your table, that it will be containing. Simply it will take, it will be having the middle element. Okay, root element, that we can say middle element, root element. Okay, it will go to this one. Okay, so your searching element is 297 2197. System won't start from here, system will start from middle. Okay, so it three with the 3800 is the root node actually. Okay, it will start from 3800. 2197 is less than this 3800 or not. Okay, it will check, it is less than this one, means it won't search for the next half of the records, it will go to left side node only. Okay, next here, in let's assume we are having four elements here. Okay, which one will be the possible middle element? Either this one or this one. Okay, let's assume this one. Okay, so what it will do, it will search 2197 is less than this one or not. Okay, so it is more than this one, it won't search for the first half. Okay, means this will be searching this one only. Okay, so next element will be what, this one only, so simply it will identify that one. Okay, in that manner it will search. Okay, clear? So it will search and you will be having the particular row id here. So directly it will go and fetch the this particular row id, whatever you are having the content for that row id, that it will search. Clear? Physically it will store in your table, and searching will be, it will avoid the half of the records. If you, for your better understanding, I am showing your data will be showing searching in the binary tree format. Binary or not, binary means two. Okay, two elements will be there, either less than or greater than. Okay, in, if you are coming from computer background means you might aware of that one, what is binary tree. Okay, if you that is searching mechanism. Okay, searching and storing mechanism. Okay, so that binary tree format your data will be stored. Clear? Till now I didn't discuss how we can create the indexes and all. Okay, just I am explaining the theory, how it will search, how it will store. Okay, how it will scan when you are doing the select star from table where particular conditions and all. Clear? uh, Yeah, sure. Once again, I will explain, because this theory is very important. Practically, just it's a matter of one statement, but internally, so much of mechanism will be there. This one, okay. Let's. Okay, you are having some employee data. Okay, let's assume you are having some 1 millions of records. Okay, employee table. Okay, so if you want search particular employee ID. Okay, what you will do? Select star from table where particular employee ID equal to, you will specify the employee ID number. Yes or no? Okay, if you are not having the indexes, what will happen? It will go and search record by record. It will go to employee ID. Okay, it will go to your employee ID, whether your record is this one or not. Okay, that 7934 or not, it will check this one. Okay, next it will go to this one till end. Next it will go to next here. Okay, your employee id this one or not, next it will go to learn. Okay, like this it will go till end. Okay, means you are scanning this much of data. Actually, where you are having the data, you are having this one. Okay, so to reach this record, how many number of records you are scanning? This many number of records you are scanning unnecessarily. Yes or no? It is there actually in the 14th record, but you are scanning 13th record. 13 records extra waste of time. Of course, anyway for searching, you will be having that one, but it is taking more time. Okay, even if your Excel, your data is sorted means simply how you can do, if you are finding 2000 line means directly you will go to particular approximately you will go to some 2000 line. Okay, it is 2197 means you will approximately directly you will go to 2000. Okay, so with that what you will get benefit, that 2000 lines of code data whatever you are there, that you are skipping. Clear? Okay, same way Oracle also will do. Okay, so if you, instead of searching this many number of records, if your data is employee IDs are in sorting, okay, if your data is already in sorted order, already in ascending order, what you will do, directly you can compare with, if you are comparing with middle element, okay, so no need to check these elements, yes or no. Next, actually your ID is here. Again, in this one, let's assume you are having here 10 records. If you are searching middle element, okay, means you can able to avoid these 5 records or not. Okay, again here you are having 5 records. If you are taking middle element, you can able to avoid these records or not, 3 records. So of course, anyway, in last you have to do some scan 2 3 records extra. That's okay, fine. But you can avoid n number of searches, n number of records. You can skip that one. Okay. Here you are having 14 records. Let's assume you are having 1 million records. Your data is some 99,800 employee ID. Okay, 99,888 is the my employee ID. I want to search my data. If you are not created the index, what will happen? You need to search entire 99,888 records. You need to search unnecessarily. Yes or no? So if you are taking the middle of the element, how many number of records you will skip? Within one step, you can able to avoid the 50,000 records. Yes, exactly. It will go to directly, it will go to middle element and it will search for that. Okay. Whether your particular element is less than that one or not. So you will skip the 50,000 left side, whatever values you are having, that left side 50,000 records you will skip. Next, in middle 50,000 1 to 1 lakh, what will be the middle element? 75,000. So 70 my record is what? 97,888. Okay, so you will, if you are comparing that value with 75,000, you can able to skip the 25,000 records again. Okay, so next you will be having 25,000. Next, in that what will be the middle element? Some 87,250. Yes or no? Okay, like that it will search. Okay, so that with comparison of one record, how many number of records you are skipping? You are skipping more than 85 90% of data you are skipping. Okay, so if you are, for that what you should be having, your data should be in proper order, then only you can able to search that one. Otherwise, if it is it is distributed unevenly means you cannot able to do that one. Yes or no? So your data should be in proper order. Okay, clear what is binary index? So all the times you are comparing, you will be having left side node and right side node. You are not having more than that. Okay, for each and every step. Do you having any other nodes here? Left side node, right side node. Do you have any other one? No, right? So all the times you will be having the two nodes only. Okay, this we can say binary. Okay, either 0 or 1. Okay, guys, yes or no? Slowly I am moving to indexes. Just I am explaining the theory how searching will be there in Oracle. Clear? Yeah, this little bit complex to understand the theory. That's why I am repeating many times. I guess this is fourth time or third time, maybe. Yes or no? Why? Because this theory is very important. Whenever you are learning in database, na, that time only you should be aware in that one. So once you are moving further, na, you cannot able to understand this topic. If whenever you are learning one database, that time you should be clear of this type of topics. Once you moving to other technologies, you cannot able to understand, but there internally it will applies this one. Okay, simply what they will do, inside that one indexes will be there, but you don't know how indexes will perform. So before that you should be having proper knowledge on the index, how internally it will works. Maybe that technology, based on technology, it may get differ, but you should be having aware of how internally it will works the indexes. How? Okay, clear, guys? Clear or not? Till now, whatever we discussed, if you are clear, I will go to practical. There are different types of indexes are there. ఏం బాబు పలకరు? Okay. Next, there are different types of index. Till now, whatever we discussed, right? That is binary index. Okay. If you are creating the index like this means, if your searching mechanism is like this means, this we can say binary index. Okay. Binary means you will be having some only two nodes, left node and right node. Okay. So means it is a binary type index. Okay, there are different types of indexes are there. One is binary index and non another. In that binary index also you will be having one unique index and non-unique index. By seeing this name itself we can come to know what is unique b tree index. Binary tree index means b tree index, we can say. Unique means you will be having only unique values. Let's assume you are having two 4,000 employees IDs. Means what? That is non-unique. You are having some duplicate IDs. Okay. So the type of things we can say non-unique index. If you are having unique values for these IDs, then you can say that is unique binary tree index. Clear, guys? Yes or no? By default, whatever you are creating, right? All the indexes are B tree indexes only. Okay, if you want to specify any other index, if you are, whether you are specifying the binary keyword or not doesn't matter, it will be b tree index only. Okay, the syntax is nothing is there for that. Just you need to specify the create index like that only. Create, if you are specifying unique means it won't allow any duplicates. Okay, if you are not using that unique keyword, then you can say it is the non-unique index. Okay, if you are using that keyword unique keyword means this you can say unique index, unique b3 index. Okay, if whatever table you are creating, right? So for that you need to specify the table name and which column you are creating the index. If you want to create on multiple columns, you can able to create that one. How internally it will work? Here you are having only one employee ID. Okay, instead of that you want to create department number as well. Okay, you can create, you can specify that 4000 comma 10th. Okay, it will be searched for the both. Okay, and what is a particular department, if you are department number, you will be anyway you will be having duplicate values. Okay, well, in particular one department you will be having more number of employees. Okay, so it will take the particular, you will be having left side also that duplicate employee department numbers as well. That will be okay, but your searching will be easy if you are creating the index on two columns. Okay, So you can create a, you can add a number of columns here. How many number of columns you are adding, that in that many number of columns you will be having the nodes. Okay, clear? I want to create the emp table means you can create, use emp table, and you need to specify the column name, emp number. Okay, this is unique. I want to create unique emp id and index, like that. I just, you can give any name here, it will work. You need to specify the keyword index data type object, and which type, whether it is unique or non-unique. Okay, if it is unique, you need to specify the unique keyword, and you can specify the column name and which column you are, on which column you are creating the index. Okay, for that already I have created index, that's why it is not having that one. Okay, let me use another table. Create table emp 100. Okay, as select star from emp. Let me create that for that column. Okay, unique index is created. If you are not using the unique keyword, it will be created as a non-unique. You can add a number of indexes for any column, any table. Okay, that is, there is no restriction for that. You can able to create a number of indexes on the table. Okay, such column already indexed. If you are created already, but you need to specify on the different column, department number. Anyway, you will be having some duplicate columns, right? So if you want to create department index on particular column means you can specify that one. Clear? If you are created as a unique queue, it won't allow any duplicates. It will be unique values. Clear? Yeah, yeah. This is the table name. This is the column name. This is this one, right? This is the index name. Okay. Yes. Table name of column name. Which, on which column you know you want to create, that you need to specify here. See, when indexes will fire, yes, exactly. When you are searching the particular element, then only your index will fire. Otherwise, if you are using this one, what will happen? Anyway, you are selecting all the data. Okay, so if you are having the index or not doesn't matter. It will, anyway, it will search, it will scan everything, and it will give the value. Okay, let's assume you are created index on particular other emp number, but you want to search on another column, job equal to some salesman. Is there any use with that? Because you are not created any index. Okay, so internally what will happen na, your system won't go to your table, it will go to your index table. Okay, if you are using a particular column, okay, index column, if you are using in the where class, system first it will search for the, it won't search for your table, it will anyway it will go to from class first. Okay, from it will go, it is table name, next it will go to where class. Okay, if first it will system will check for the, whether on this table, on this column you will be having any index tables in for this table or not, in it will search in the your metadata. Okay, if your index is created, if index table is created in your metadata, system won't go to your table data, it will go to your index table only the time. Because if you are going for table means, what will happen again? It's a waste of time. Yes or no? Okay, the system will check for your column, index column, this where class column, filter column, on this column, we have any index table or not? Okay, it will go and check and it will search for that. If it is exist, it will take the only that particular index table and it will scan this one. Okay, in this way it will search. Okay, so here you are having on which column? Sales job column, there is no index is existed. So that time what it will do, it will go to your table only. It won't go to your index table because there is no index column, index table here. Okay, it will check for your table only. If you are using employee number, system directly go to your index table only, not for the your table data. Okay, it go to directly here and it will scan here. So what will happen with this one? You will be getting the very fast. You are skipping more number of records or not for searching. Okay, that is the rules. If you are creating the index means you should be, that index column should be in there in the where class. Clear? Yes, I'm coming to that one only. Next slide is that one only. So we can create the indexes automatically or manually. Okay, automatically means if you are creating the any primary key or unique constraints, constraint topic will come. Okay, if you are creating the constraint means few, okay, that unique index will be created automatically. Okay, I will explain one more time the same topic. Okay, okay, primary key, there will be some other features as well for that. Okay, so what primary key internally will do, just by seeing the definition not null and unique, okay, but internally there is a lot of features. Okay, one of the feature is this one. Okay, by default internally it will creates the unique index. Okay, whenever you are creating the primary key, by default it will create the unique index because internally it will be having unique constraint. So unique constraint means unique constraint, if you are creating the unique constraint means you are creating the unique index as well for that. Okay, so internally it will create that one. Okay, manually if you want to create, I don't want to go with the indexes and all. Okay, then you can create manually also. That is, syntax is this one only, just now we discussed, right? Create index name. Okay, you can specify the particular index type and you can specify the name and which table which column. If you want to create externally means you have to go with the unique, this syntax. Okay. Hmm. Why? You can add here itself, right? EMP number, DEPT number. You can add a number. Yeah, here itself you can add a number of columns. Just make sure that column should be there in your table. That's it. Okay, doesn't matter whatever you are having, how many number of how many number of columns you are creating. That and all doesn't matter. Okay, so if you are creating like this means unique index means this combination should be unique. Here it is not the only EMP number is the unique. This combination should be unique. Okay, if you are inserting 1 1 again means it will avoid that one. If you are inserting 1 2, okay, let me create one table. Create table tab underscore dope, that is a number, b number. Yes, we already listed. Table, table. Say we are kept to. Okay, let's assume we have created the table with three columns. Okay, I want to create the index on two columns. Okay, you can able to create that one. Okay, I want to create. If you are creating unique index, you cannot enter this combination as a duplicate. If you are not creating the unique index, it can allow duplicates. Okay, just that is the difference, but searching mechanism will be same thing. Clear? Okay, next go. No, actually, in real time depends on organization. Okay, if you are creating the constraints, na, that will be charge, additional charge for the organization. Okay, so you know cloud, right? If you are utilizing one feature, okay, that will be added to your billing. Yeah, okay. Same way in Oracle also. If you are creating the materialized views, if you are creating the constraints, if you are creating the partition tables, okay, so that are now will comes for the additional billings. Indexes will not come for the additional billing. This for common feature. Okay, we work for the terminals. There actually we created application. Okay, so we never created the constraints and all. Okay, so same features we can enable with indexes as well. And also if you are creating the constraints, your data should be very proper. Okay, it cannot insert the record. Uh, it won't insert the means unwanted data. Okay, means the data should be very proper. Okay, it all the times you will be getting the that violation errors if you are inserting the more duplicates that and all. Anyway, that is matter, but normally that constraints and all will go for the relationship, building the relationships. Okay, so that if you are having the relationship, if you don't have that record in the parent table, still you want to insert the data in child records, means you cannot insert that type of things. Okay, if you are creating the primary key and foreign key, you should be having proper relational data, otherwise your data cannot insert. Okay, I will show you. Okay, just will take very small example. Okay, and I will show you if you how many drawbacks will be there with constraints. Okay, yeah, money wise costly. Okay, anyway, we don't need to think of money. Anyway, that will take care of this one. Okay, that doesn't matter for us, but we need to think of data. Okay, if we do, as a developer you have to take care of DML operations. Okay, if your data is not there in the parent table, you cannot insert the data into the child record. So what you have to do, you have to take care of all the places. You have to insert the data for parent table, and again you have to insert the data for child table. Like that, you need to take care of lot of things. Okay, if you are having the primary key and foreign key relationships. Okay, so there will be lot of additional things you need to take care if you are going with the primary keys and all. Yeah, there will be lot advantages also. Okay, as a developer you will get suffer lot of things, but all the times you will get the errors, violation errors. That is restrictions you can do, but at the same time you have to take care of the data as well. Okay, so let's but if you are going with the indexes and all, there is no much restrictions. So okay, that primary key whatever you are there, right? So internally it will creates the searching mechanisms and all advantages. Okay, with indexes also you can anyway by default it will do the same thing only. Okay, so it will create that one, you can able to search your data very fast manner. Okay, so you have created the index, right? So I want to create as a unique queue without, this is already existed. Okay, with this name, because this is the name one, that's why it is showing error. Okay, let me create on the tape loop. Guys, don't think of whatever columns I'm giving, just for time being. It is for type speed. Okay. So tab loop underscore index, like that I will create. Next, try to insert the data for the table. Insert into table values. What you can do, how many columns? One. You can give some a. Okay. Here it will allow. Okay, you are inserting the data. Next, you can change any column in the first two. It will allow. Okay, because you have created the unique index on the only first two columns. Okay, it will allow. Next, you can try to insert the same record once again. Okay, even though if you are changing this value, system won't allow because unique constraint violated. Okay, why? Because you are created the index on the only these two columns. Okay, these two columns mean this combination should be unique. One already you have inserted. Okay, so system should not allow, system won't allow the this duplicate record. Clear? Okay, you can, if you want, you can drop, you can alter that and all, you know already. Okay, same thing, drop. If you are specifying, that means your index will be dropped. If you want, you can insert the data as well. Clear? Okay, if you want to create non-unique index, okay, no matter whether I'm inserting the data duplicates or not, doesn't matter. Still I want to query data very fast and all, means I want to insert the data in tree structure, or I want to get the data very fast manner. Okay, even though I am entering the duplicates, you can able to create the b-tree index with this one. Okay, just you can create this one. Already we have created, right? Okay, now you can try to insert the same records once again. System will allow. Here, three rows inserted. Already you are having the data. I cannot showcase your data is fetching more faster. Okay, because my data is more of 6 or 10 to 15 records. You can able to identify. Okay, you can able to you can come to know once your data is more. Okay, if you are having some 50,000 or 1 lakh records, okay, that time you can come to know your how much advantage you will get with the indexes and all. Okay, for smaller amount of data you cannot able to notify that one. Okay, advantage of index, but internally what will happen, that one you come to know. You came right already. You understood? This is the b-tree index. Okay, so can anybody tell me what are all the rules you need to follow for the creating the indexes and all? Till now whatever discussed, you should be using that index column in the where class, then only your index scan will go. Otherwise system will go for the full table scan. Clear? Okay, you are searching your data means what you are doing, scanning. Okay, system in system language we can say scan, in our oral language we can say searching. Okay, so if you are using that index in your where class, then only your system will go for the index scan. What is index scan? It won't go for the table scan, it will go for the your index table. Okay, here it will go and it will search for your middle element and it will comparison will happen, so that you can able to avoid the n number of records. Clear? One is clear, right? What is index scan? Next, you should be having not equal operator. Not operator you should be having. If you are having null values, is null, use not null. Okay. If you are using, even though if you created the employee table, okay, still you are okay. Still you are using the where EMP ID is null, where EMP ID is not null. such type of things you are using means you cannot able to scan the index scan. Okay, you cannot go, your system won't go for the index scan. And also if you are applying any function on the index column, it won't apply because your data is applied on your what, actual value. Okay, so whatever value you are having, for this one only you are having. Okay, if you are modifying, okay, let's assume emp number is having trunk of emp number, or some round of emp number. Okay, if you are doing like that means system won't scan for this because you are having only this actual values of this one. Okay, you are not applied on any functions and all. Okay, system, you should not use any functions for that. And also you should, system should not contain the is null and is not null operator and not equal to operators. You should not use that specific operators. If you are using any this type of operations, system won't go for the index scan. Okay, if you are using this type of operations all the time, system will go for the full table scan only. Clear? So I hope you everybody is clear what is B-tree index and in that how it will search. Everybody is clear, right? So if you are going with B-tree index, what will happen? Internally, it will create the one table for the index column, and you will be having the offset column. Here you will be having the row ID and actual particular column as a your all the values it will be storing here only with as a offset value. Okay, offset row id and 1800 whatever record you are having, that it will create here. Clear? Your entire data will be storing with along with your row id in the offset column. Okay, so here row id some a, let me show you that one as well. How internally. Okay, so like this you will be having row id. Along with this one you will be having 1800 and you will be having that okay, that emp name and whatever columns you are having, right? So everything will be stored in the separate table. Clear? So yeah, the unique queue means only it will allow unique values, and scanning also will do same way. Non-eq means even though it will allow the duplicates, but still your data will be stored in your index table only. Clear? B-tree index and all. Next, we are having another type of. Okay, let's assume I am having population table. Okay, I want to create index on male and female. Okay, gender column. Sorry, guys. Sorry. Okay, I want to create a index on gender column. Means you will be having value as M or F. Okay. Nowadays people are adding transgender also. Okay. But you will be having only less number of values. But India population is how much? 140, 140, 130 crores. Okay. If you are creating the binary index, is there any use with that on the gender column? You will be either you will be having M or F. That's it, right? Okay, there is no use of creating the index for the binary index for such type of columns. Okay, means what is that? Cardinality. Okay, cardinality means for particular column, what are all the column number of unique values? Okay, transaction type, debit or credit. Okay, gender, male or female. Okay, departments you will be having. Okay, let's assume one organization you will be having some 1 million of employees are there. Okay, let's assume 10,000 employees are there. How many number of departments will be there? Maximum, max to max, 4 to 5. Okay, if you are creating the in a binary index on the such type of column, okay, department number, is there any use with that? No. Okay, simply it's a waste of time. So what you can do for the, okay, still if you want to search such type of things means you can go with the bitmap index. Okay, wherever you are having the cardinality is very low. Okay, so such type of columns, if you want to create the indexes and all means, you can create the bitmap index. Okay, how internally it will works now. Okay, system will create the, let's create one topic by seeing this one. Okay, let's assume this is the table data. Okay, it is the gender, you are two columns you are having, customer id. Okay, let me open that excel only. Okay, these are all the employee table. Okay, next here, name, email. Next, gender. Next here you will be having some salary, something like that you are having. Okay, let's assume you are having some employee id like this. Okay, ఇది డ్రా అవ్వట్లేదు. I'm having this many number of employees. Okay, ABC one like that I will be having. Let's I am having estimate of. మీకు డ్రాగ్ వర్కౌట్ కదా. మేలు ఓకే, ఇది ఏదో సమ్ వాల్యూస్ ఉన్నాయి. ఓకే, so I don't want to consider this column. I want to create the index on particular column. Okay, this rarely people will use the bitmap index. Still interviewer will ask what is the bitmap index. Okay, if you want to create low cardinality, cardinality means number of unique values. Okay, for this type of values, if you want to create the unique values means, system what it will do now, you can able to normally you can go with the bitmap index. How internally it will performs now, system will create separate table. If you are creating the index means, internally what it will do, it will create separate table. That's you are already clear. Okay, so here you are having the index column and you are having the offset value for the binary tree. But in case of bitmap index, what will happen now, separately it will create that one. Okay, if you are creating on which column, gender column. Okay, so if you are creating the bitmap index, what are all the values for the gender column? Okay, that it will create separately. Okay, separate columns it will create. Okay, m and n, f, it will create the separate column. Okay, and what are all the values you are having, these are all the values. Yes or no? Let me take this value. Okay, so for this ids it will take. Next, it will create the separate m and f, right? So wherever you are having, okay, in all the places it will be give the value as a 1. Okay, here you are having the value as f, right? So here you will be, that bit value will be f. Okay, so like that it will be created. By seeing this table you can come to know easily. So it will create that one. Rest of the values it will be zeros. Sir, bits means either 0 or 1. This already you know. So internally what I am telling here is, instead of searching your string internally, if you are going with your bits, scanning will be very easy. Okay, let's assume you are doing some transaction type here. Okay, credit and debit, complete name you are having, credit, debit. Okay, if you want to search 5 characters means will take lot of time. But if you are placing for credit as a one column, debit as a one column, and if you are having the values as a zeros and ones, okay, it will be easy for searching. Clear? Yes or no? Compared to string column, number column will be very easy. That too, if you are having only two values, that is with number, okay, 1 and 0, that is very easy. Okay, so I want to get only male members in the organization. How we can get? Simply what you can do, select a star from table where gender equal to male. Okay, that time system what it will do, it will go for the your index table, and it will search where whatever values you are having the one in this table, it will pick that values. Okay, it won't consider the next records and all. Clear? This is the bitmap index. Yeah, yeah, okay, yeah, yeah, let's take, this is here department number also you are having. Okay, let's creating the department number here. Okay, let's assume 40 also. Okay, you are not creating the index on male and female, you are creating the index on department number. What will happen? How many number of unique system will go for this one, and how many number of value unique values are there with the department? Okay, that you can identify and it will search for that. Okay, so you are having some 10, and next you are having some 20, next you are having some 30, next you are having 40. Okay, actually it won't replace zeros and all, only it will place the one values only. Okay, so system what it will do, first record is what, 10th. Okay, so here it will place 1, next here it will place 1, next 20, in 20th column you will be having place 20, next this is 30th 1. Okay, next what is that one, next value will be 1. Okay, next 40th. Okay, you will be having the one value here. Okay, so if you are querying the only 20th department, what will happen? Wherever you are having that one value, that it will take, it won't consider for other ones. Okay, if you want to fetch only 40th department, okay, simply it will go and search for the where you are having the one value. Okay, simply it will query and it will give the that particular result. Clear? How many number of unique values are there, that many number of columns it will add. Okay, even this, see, let's you can go for the binary index, you can create the emp number. Okay, how many number of columns come here? Only 4 you are having here. Yeah, all are unique value. Okay, if you are creating this one, for each and every record you are creating the separate column, what will be the use? Okay, all the times you have to scan all the columns. Okay, for identifying the column names itself will take time. Okay, so you need to check which type of index will be suitable for per. Okay, if you are having duplicates, it will be easy. Okay, you can go with this one. Sir, no. If you are creating for this column, if you are creating the unique index, what will happen? There is no use with that. You will be having parallel n number of nodes. Okay, see, again it will you will be going for the index table, complete table. Yes or no? So you have to match the particular index. Okay, by seeing by analyzing your data, you can come to know which type of index you need to create. Clear? Okay. So again, here also it will applicable. You cannot apply any not null this whatever columns you are having, right, index column. Okay, so these rules will be applicable: is null, is not null, and that not equal to operator, and you should be having that index should be using in where class, then only it will fire, otherwise it will be waste only. Okay, so this type of things will be applicable here as well. And you should not contain any functions, you should not apply any functions on the index column, then only you can able to go for the index scan in these methods. Okay, clear what is bitmap index? Okay, how we can create the bitmap index? Just you need to specify that. Okay, let's create the bitmap index on the job table. Okay, job column. Okay, because you are having the how many number of designations we will be having in the organization? Only few. Okay, assistant engineer or software engineer, senior software engineer, team lead, senior team lead, manager, senior manager. Okay, or you will be having some president, vice president also. Okay, okay, maybe more or less it will be having more or less than 15 only number of designations in the organization. But how many number of employees will be there in your organization? Maybe it's a depends on company size, right? So let's assume your organization is having 10,000 employees means, so you don't have that many number of designations, you will be having less number of designation. Okay, if you want to create such type of things and all means, you will go with the bitmap index. Okay, how you can create the index means, just you need to specify the keyword bitmap. Okay, create bitmap index, index name or table, and which column you are creating, that you need to specify. That's common thing. Clear? This already I have created, that's why it is giving error. Okay, let me create this one. Do not attempt this feature because this feature is enabled. Okay, so I am using trial versions, right? So that's why it is not allowing. If you want, you can go with the Oracle Live SQL. There you will be having, you can able to create the bitmap indexes and all. Okay, in my real time I never created the bitmap indexes and all, but it is the very important. Very rarely people will create this type of indexes and all. Okay, this is clear, right? Next, one more type index also there, that is function based index. Okay, function based index. Till now, what I told, you cannot apply any functions if you are having means sorry, you cannot apply any index scan if you are having any, if you are applying any functions on the columns, right? Okay, and one more thing, indexes are not only for the number fields, you can able to create for the character fields also. Okay, bitmap indexes we have created for gender, right? Same way you can create for the your columns also. Okay, what it will take internally, your ASCII values only. Okay, so internally it will work that one only. Okay, but even this index table also we cannot able to see, but internal mechanism is that one only. Basic rules will apply all the times. Okay, next, if you want to create still, okay, I want to create index on function. If let's assume all the times I want to use the trunk function, all the times I want to use the some upper function in whenever I am querying the data. Okay, still I want to create the indexes and all this. You will go with the function based index. Okay, so how you can create? Just you can specify that index name and emp, and along with column you need to specify your function. That's it. Real time rarely will use this type of things, but still we can create the function based index as well. Okay, whatever function you want, that you can specify that one. Okay, this index will be created. Clear? Internally what it will take? Hmm Again it will create separate table for that. Nothing with that. Don't forget the original topic. That's why I explained very first theory. What will be there internally? Index means it will be create separate table only. But earlier you have created on the column. Now it will be created along with your function, not on the direct column. Okay, function of, okay, employee name. Okay, what is my function? Upper. Okay, upper of why, no matter what value you are inserting, whether lowercase or uppercase, system will convert into the uppercase, and it will insert the data into index table. Okay, that is the thing. This is, we can say, function based index. Okay, for this one what you have to take care, all the times you should use the function in the where class, otherwise it won't fire again. If you are using the same function in the where class, then only it will fire, otherwise it won't fire. Clear? Anybody have any doubts in the index topic? This is very important. Internally how it will work, practically by seeing this one nothing will be there. Create index name, create bitmap index. By seeing this one you cannot understand anything. For this type of things you should be aware of internal mechanism. For other topics, whatever earlier we discussed, right, you should be aware of how we can write the logic internally. What is the how it will performs, that you are doesn't matter for you, but you should be having that internal you should be able to write the query. Okay, you should be able to use the proper logic for that. Okay, so for that indexes and all, you should be having internal mechanism, that knowledge and all. Okay, then only you can able to create the proper indexes for that. Clear? Anybody have any doubts? If you are having, we can discuss, otherwise we can close this one. Okay, don't forget tomorrow. I will take this constraint topic.